Hey guys, welcome. We're going to do the homework for 6-1 and I'm going to show you the multiple choice here. Okay, so here's our problem set, and here toward the end we've got exercise 31 through 34. So this facts are going to be the same for the first 3 questions. So let's take a look. It says choose an American household at random and let the random variable the number of cars, including SUVs and light trucks, that they own. So here's the probability of distribution if we ignore a few households. So this has to add up to 1. So I actually just double checked it in my calculator before I hit record, and it did add up to 1. And so we're essentially saying it's just infinitesimally small, that it's more than 5. And so what we've also seen done is that they do this, right? 5 or more, so that you make sure you get all of it. It has to add up to 1 or this won't work. So what is the expected value? Now, remember we took in our notes, I call it this times this. It sounds a little hokey, but it's how I remember it. So I'm going to take this times this plus this times this plus this times this plus this times this. Add all that up, and that's our expected value. So our expected value is equal to adding all that up. So that'd be 0 times 0.09, 1 times 0.36, 2 times 0.35, 3 times 0.13, 4 times 0.105, and 5 times 0.02. That all adds up to 1.75, and that is one of my answer choices here. So there we go. Okay, so kind of borrowing the same fact scenario, they ask us a follow-up question. They don't make us calculate it, so that was nice of them. They said that the standard deviation is 1.08. So let's think about what that means. What we're saying is any random family that I might select, I'm expecting that for them to have 1.75 cars, right? And I think that makes sense. So somewhere between 1 and 2 is what my expected value is. So, right? And I didn't look at this distribution, but it makes sense that would be somewhere in the middle. Now they're saying I should expect for it to vary about 1.08 from that 1.75. So that's essentially what the standard deviation means. So again, in our notes said that we would expect the number of cars per household to vary by about 1.08 cars from the mean of 1.75 cars. Okay, that's what standard deviation means. So if this is what our script says, we're going to look for which one looks to be saying the same thing. So it says a mean would be, no, not the mean. The number of cars would typically be about 1.08 from the mean. Exactly. So the number of cars we would expect would typically be about 1.08 from that mean. And that's exactly what we've got there. Nice. 33, same fact scenario. I actually copied and pasted the table so I wouldn't have to like flip back and forth, but this is this same table from here. I just copied and pasted here. So it says about what percentage of households have a number of cars within 2 standard deviations. Okay, so if my mean is 1.75, within 2 standard deviations of the mean would mean I'd either add or subtract that, right? So mu minus 2 standard deviations and mu plus 2 standard deviations from that mean, and that would be within that. Okay, so my mean is 1.75, and I want to add 2 times the standard deviation, which is 1.08. And I also want to know the number that's 2 standard deviations less than the mean. So 2 greater than the mean and 2 less than the mean. So let's just kind of calculate this All right, and here I'm subtracting 2.16. All right, and now I'm looking in the table, which one is within there. So it looks like I don't get all the way up to 4, so I can't do there. And I can go all the way down to a negative. And you can't really have a negative car, but so that would be the expected value is 1.75. And then this is 1.08 to the left and to the right. So it looks as if I'm including everyone but these folks that have 4 or 5 cards. Those are the only groups of people that are not within 2 standard deviations of the mean. So kind of, I could add these up, right? I could add these up, or I could just do the complement. I know that 7% of people are not included, so 1 minus 7% would be 9.3, and then that's my answer. 93% of people are within 2 standard deviations of the mean. Okay, last fact scenario, a new one. A deck of cards contains 52, of which 4 are aces. So we look here and we see that the probability of an ace is 4 out of 52. Now it says you are offered the following wager. Draw 1 card at random from the deck. So I'm only going to be drawing 1 card from the deck. So my probability of an ace, if I draw 1 card from the deck, is 4 out of 52. It says I win if the card drawn is an ace. You win if the card drawn is an ace, and I get $10. I lose if $1 if it is not an ace that is drawn. If you make this wager many, many, many times, what will be the mean amount you will win? Okay, so let's calculate that up. And notice I need a probability table like this. And so in our notes, this is X, right? The number of cars. And this is the probability of X. The likelihood of having 0 cars was 9%. The likelihood of having 1 car was 36%, right? And so we need to kind of create this same table where we have X and the probability of X. So, and that will allow us to figure out, if I make this wager over and over, what will the mean amount be? What should I expect to win over the long run? What they're really asking is, what is the expected value? Okay, and my formula for the expected value is this times this, right? So if I'm going to do this times this, I need the table. I can't do it without my table. So I'm either going to get an ace and win my $10. So X just stands for how much I'm going to win. And right. And then here, $1 would be if I don't win. So 4 out of 52, I'm going to win, which means 48 out of 52, I would not win because, of course, this has to add up to 1. So now I'm going to use my formula for the expected value. My expected value would be 4/52 times 10 plus 48 52 times 1. And I get, oh, be careful here, right? I lose $1. So that's very important, isn't it? I got to include, this is a negative. So 4 divided by 52 times 10, so 76.9, and then 48 divided by 52 times -1. So I'm getting -15 cents, and that is one of my answers here about, in the long run, I should expect to, on average, lose 15 cents if I keep playing this game. Thanks for joining us, guys.